A very good morning to you all. Myself, Dr. Midul Setia, Assistant Professor, Department of Chemistry, DR College, Gulaghat, Assam. Today I am here to discuss a topic on groundwater arsenic contamination, health hazard, and its removal techniques. As you all know that natural potable water resources becoming exceedingly a limited reserve for the human race throughout the world. Furthermore, presence of varied numbers of pollutants, including heavy metals in the water, through natural or anthropogenic interventions, imparts toxic and harmful effects to the environment and the individuals. Among the pollutants, arsenic is considered a high priority toxic metal because it acts as a human carcinogen. The arsenic contamination of drinking water is among the most worrisome environmental health challenges nowadays, threatening the well-being and livelihood of more than 100 million people worldwide. The presence of arsenic in groundwater has been reported extensively in recent years from different parts of the world, including countries in North America, Latin America, Australia, South Asia, China, Nepal, Vietnam, Cambodia, and India. However, the environmental problem of arsenic toxicity in groundwater of the entire Bengal Delta of the Ganga, Padma, Meghna, Brahmaputra river plain, covering several districts of West Bengal and Bangladesh, creates apprehension toward the scientific community and considered as the worst arsenic affected alluvial basin. The magnitude of the severity in respect with arsenic toxicity in the region where subsurface water is primarily used as a source of drinking water is very high. In Bangladesh, 28 to 77 million people drink arsenic contaminated water without having alternative resources. The Bengal Delta Plain is formed by the Ganga Brahmaputra river system, the 13th largest modern delta in the world. More recently, the scale of the problem in other states adjoining the West Bengal with a similar hydrogeologic pattern like Assam, Tripura, Manipur, Arunachal Pradesh, Nagaland, Bihar, Jharkhand, and Uttar Pradesh has also been reported. In northeastern India, the presence of arsenic has been identified in 21 districts out of 24 districts of Assam, and in 3 districts in Tripura, 6 in Arunachal Pradesh, 1 in Manipur, and 2 in Nagaland. However, the problem of arsenic in groundwater-related health hazard in Assam is yet to get enough systematic attention due to its recent emergence having few review reports. Dear participants, so nowadays it's a very big problem. The contamination of water by arsenic and its health hazards is a very big problem in all over the world. Therefore, it is our duty to develop techniques, methodologies by which we can remove arsenic from drinking water. So in this presentation, I will discuss mainly the different techniques so far developed for the removal of arsenic from drinking water. But before that, after the presentation, you will be able to learn something about the introduction to the groundwater arsenic contamination, a brief idea on the element that is arsenic, different uses of arsenic compounds, health hazard due to arsenic in drinking water, and lastly, removal of arsenic from groundwater. So before we start, let us know actually what is arsenic and what's the position of arsenic in the modern periodic table. So here As is the symbol for arsenic, having atomic number 33 and mass number 74.92. The position of arsenic in the modern periodic table is 15 group, 4th period, and it is a p block element. And it is Albertus Magnus uh, is believed to have been the first to isolate the element in the year 1250. Arsenic, the element, is not new, but it is though not well known in the ancient time, but its compounds were used in the ancient time. So in the ancient time, arsenic and its compounds were used as therapeutic agent and a poison, especially uh, in Greece and Rome. And the interesting thing is that the Italian family of Borgias used arsenic as their favorite poison for political assassinations. It is believed that Napoleon was poisoned by arsenic tainted wine served to him while in exile. Now, let us see what are the different uses of arsenic and its compound. During the 18th, 19th, and 20th centuries, arsenic compounds used in medications. The ruling class in ancient times used to murder one another. That is the poison of kings, or you can say the king of poisons. Arsenic used in the manufacture of glass to eliminate the green color caused by iron. Arsenic compounds are added to lead to harden it. Werfer poison gases as Lewisite and Adamsite, lead arsenate, calcium arsenate, and Paris green teach nothing but insecticides. Arsenic compounds such as gallium arsenide is used as semiconductors, and arsenic sulfide can also be used as pigment in the manufacture of fireworks, paints, etc. And these are all about the different uses of arsenic compounds. So this is a picture showing different uses of arsenic compounds. So if you see the position of arsenic in the world, its rank is 20th uh, in the earth crust and 14th in seawater, and in the human brain its position is 12. Yes, this is the sum of the arsenic facts. Naturally occurring arsenic in the earth crust, it has more than 200 mineral species. The concentration of arsenic in the soil is around 3 to 4 ppm parts per million, and in water it is 1 ppm, that is it greater than 1000 ppb, and most prevalent in human toxicity is due to inorganic arsenic, and especially inorganic arsenic in water, drinking water, is in the form of some arsenite or arsenate ions. It has specially 3 oxidations this plus 3 plus 5 and 0 oxidation is this. So organic arsenic is found in soil, species, marine organisms, and generally these organic arsenics are less toxic. It has mainly 3 allotropes: alpha or it is yellow arsenic, beta or black arsenic, gamma or gray arsenic. So mainly it has 2 valences when present in water, drinking water, in the form of ions S3 or in the form of ions having oxidation state 5. In natural water, arsenic is mostly found in inorganic form as oxygen ions of trivalent arsenite or pentavalent arsenate. Arsenic 3 is more toxic than arsenic 5. Now, if we see the properties of arsenic, then the general properties, among the general properties, its chemical series is metallite, its group is 15 in the periodic table, 4th period, and it's a p block element, whereas its appearance is metallic gray. And if you see the physical properties, it is generally solid phase. Melting point is 1090 Kelvin, boiling point is 887 Kelvin, and it has different isotopes like 73 arsenic, 74 arsenic, 75 arsenic. Isotope means uh, species having same atomic number but different mass number. So it has the notable characteristics like very similar to phosphate, forms colorless crystalline oxides like arsenic trioxide, arsenic pentoxide. On heating, it gives arsenic trioxide. Elemental arsenic, it is maybe yellow. It is yellow, soft and waxy. Gray arsenic is always in the form of rhombohedral and is hard. Now let us see the different sources of arsenic. So if we see the natural sources of arsenic, the natural source of arsenic is nothing but minerals, and generally in the form of oxides or sulfides. And the different sources of anthropogenic sources of arsenics are metallurgical plants, cement industries, glass manufacturing industries, wood preserving industries, and the pesticides production and application, coal and oil production and processing, and these are different sources of anthropogenic sources by which arsenic can come to water. Now let us see what's the effect of arsenic due to consumption of drinking water. And the arsenic toxicity is divided into 2 categories. The first one is acute poisoning, the second one is chronic poisoning. So within approximately 30 minutes of exposure, a person may have reddish rashes in the body and intense thirst, but difficulty in swallowing, dry mouth with breath having slight garlicky odor. Clinical symptoms include weakness, muscular cramps, and abdominal pain, nausea, vomiting, and profuse diarrhea. Effect on mucosal vascular supply leads to capillary damage, slowing of tissue fragments, vasodilation, and vasogenic shock. Skin turns into cold due to circulatory failure, beside decreased urine output and kidney damage. Cardiac indicators include subendocardial hemorrhages, acute cardiopathy, and electrocardiography changes. And if you see the chronic poisoning, then chronic nature of poisoning is more treacherous as accurate diagnosis of symptoms is very difficult. Arsenic-related dermatosis often wrongly mixed up with other related indications. Skin, liver, lungs, and blood systems are mostly affected. Non-specific but typical cutaneous vicissitudes and early persistent erythematous flush that leads to melanosis, hyperkeratosis, etc. etc. Palms and soles are also affected by diffuse dequamation. Continuing skin problems lead to development of multicentric basal cell and squamous cell carcinomas. So this is nothing but a picture of skin lesions, and this is a picture of arsenic patient due to long-term exposure of arsenic. And similarly, these are the pictures of chronic arsenic poisoning, and some photographs of carcinoma, hyperkeratosis, conjunctivitis, bronchitis, severe skin cancer, etc. And it is palm of arsenic affected patients, sole of arsenic affected patients, patients suffering from filaria due to arsenic. Now, arsenic contamination, groundwater. So we have different groundwater sources. It may be deep tubules, shallow tubules, terra pumps, and uh, irrigation system also. An irrigation system, deep irrigation, the arsenic can come to the paddy field also, and thereby the water of drinking water can be contaminated. So this is a map showing different areas, different countries of Asia. So the red spot are the countries or the areas in which the water is contaminated by arsenic. And yes, this is the picture, this is the main area, that is the Great Ganga Basin. The Great Ganga Basin was badly affected by arsenic. So now let us see the burden of arsenic. So from a study, it has been observed that 94 to 20 million people worldwide are potentially exposed to high arsenic concentration in groundwater. And if we see the area was global distribution, then you find that 64% area in Asia has been contaminated by arsenic, 40% area in South Africa, 10% in North America, 9% in Africa, 2% in Oceania, and 1% in Europe have been affected by arsenic. And similarly, if we see the calculation of globally affected population, then we can say that 94% population in Asia have been affected by arsenic poisoning, 1.6% in South America, 0.6% in North America, 0.2% in Europe, and 0.01% in Oceania have been affected by arsenic. So, from the above discussion, it is very clear that the arsenic in drinking water and health hazards creates a very uh, big problem, not only in Assam or not only in Northeast India or not only in India, Bangladesh, but all over the world. That is why it is very urgent. It is very, it is an urgent need for immediate relief to those using drinking water with high arsenic concentration. That means right now we need such a technology, we need such a system, the method by which we can remove arsenic from drinking water so that at least we can control the health hazard due to drinking of arsenic contaminated water. Uh, yes, and it is the regulatory drinking water standards of arsenic. US EPA, that is United States Environment Protection Agency, uh, who India, Bangladesh, and many of the countries have decided their permissible limit of arsenic in drinking water. And the US EPA, that is United States Environmental Protection Agency, have set the value as 10 ppb, whereas the whole limit is again 10 microgram per liter, that is 10 ppb. And in India, it is also 10 ppb. Uh, in Bangladesh, it is 50 ppb. Likewise, different countries of the world have set their permissible limit of arsenic in drinking water, and actually it is based on the food habit, different instruments and processes available in those countries, and some other factors. So now let us come to the main point, that is overview of mitigation options. What are the different mitigation processes of uh, removal of drinking arsenic from drinking water? So the arsenic mitigation process can be divided into two categories. In the left hand side, you see I have showing you some alternative arsenic free sources, and in the right side I'm showing you some arsenic removal technologies. That means uh, the problem of arsenic in drinking water and the health hazard can be controlled or can be minimized uh, by different ways. If your drinking water is contaminated by arsenic, then what you will do? So for that, first we have to see the alternative arsenic free sources. So safety wells, improved dug wells, deep wells, the rainwater harvesting, surface water treatment, or the surface water. These are nothing but some of the alternative sources of arsenic free water. And so far research is concerned, so far survey report is concerned, we have seen that most of the uh, waters taken from deep wells have been affected by arsenic poisoning. And so far my research is concerned, I have seen that In my area, that is in the Gulaghar district, there are some arsenic minerals, and from that minerals, arsenic is leaching out and contaminated the drinking water. So the same case is also happening in most of the parts of the world. So in that case, what should you do? That we have to, if we don't have any alternative arsenic free sources, if we don't have dugwells, or if we don't have ponds or surface water, or if we don't have rainwater harvesting systems, then we have to remove arsenic from our drinking sources, that is from the deep wells. So in that case, arsenic from that contaminated water, from that water, deep wells or deep borings, we have to apply some techniques. So I have shown you the techniques: the aeration, oxidation, coagulation, precipitation, absorption, ion exchange, membrane techniques. These are the renewable technologies. So I will discuss all these renewable techniques one by one. But the primary methods for removing arsenic from drinking water are lime softening, coagulation assisted microfiltration, in the short form it is known as CMF. Third point is coagulation cum filtration. Then ion exchange to remove anionic arsenic by using reagents. Then fixed bed adsorption uses adsorbent, typically a metal hydroxides such as activated alumina or ferric hydroxides. Then oxidation filtration, that is they are oxidizing uh, reduced iron to remove arsenic through sorption, co-precipitation, and coagulation. Then physical filtration used to remove colloidal bound arsenic. Then membrane processes, that is for the removal of arsenic by reverse osmosis or nanofiltration. These are some of the primary methods for removing arsenic from drinking water. So now let us discuss all these methods one by one in detail. The first one is lime softening. Arsenic oil can be increased effectively at higher pH through precipitation using lime softening treatment. Lime softening is commonly used to remove magnesium and calcium cations from solution. Lime is added to increase the pH above 10.5 to form magnesium hydroxide, which is then co-precipitate with arsenic 5. The process is thought to be a combination of sorption, co-precipitation, and occlusion on the calcium and magnesium solids. Iron oxidation through aeration or chlorination also results in arsenic removal. Therefore, arsenic removal may be targeted indirectly through iron removal. Then the coagulation and filtration process. Iron in the oxidation state 3 or aluminum in the oxidation state 3, salts are used to form flocks and sorbs and co-precipitate the dissolved arsenic, which are subsequently filtered out. The precipitated iron hydroxide or aluminum hydroxide can be removed either by granular media filtration or membrane microfiltration. If granular media filtration is used, as flocculation step must be included to facilitate growth of flock particles. Use of a membrane microfilter is a better alternative to get the desired result. Then sorption, and under this category, let us discuss first the ion exchange process. It is a process of physicochemical ion exchange between a solid resin phase and a solution phase. The technology is widely used for contaminant removal from water, with familiar applications of this technique involves use of cationic exchange of sodium ion for calcium and magnesium ions in case of home water softeners. This technology is applicable for low volume drinking water applications. Then, arsenic absorption using fixed bed. Absorption of arsenic onto metal oxide or metal hydroxide surfaces has been well known for many years. Absorption based systems usually utilize metal oxides such as iron hydroxides, ferrihydride, zirconium dioxide, titanium dioxide, etc. etc. These metal hydroxides or the metal oxides have excellent arsenic selectivity. Typically, they form inner sphere complexes with the metal atoms in the solvent using oxygen bridges. This process is economic and having easy working conditions and accessibility of low cost absorbance. Then arsenic removal by layered double hydroxide. Layered double hydroxide or hydroxide like compounds with a general formula, though I have not written here. So it has a general formula M2 plus 1 minus X and 3 plus X OH2, and, and the charge is X plus AX negative charge and n number of atom molecule can be considered as a good adsorbent for the removal of toxic arsenic from water. A large surface area and high anion exchange capacity of LDS, the compound may be a good adsorbent for the removal of arsenic from contaminated water. And I have given you the information that in my research, during the time of my research, I have done a lot on the particular layered double hydroxide compound, and I'm using it for removing arsenic from drinking water. And in my study, I've observed that calcination rehydration reaction in batch experiment showed removal of greater 98% arsenic from a solution by adsorption process that follows the friendly type adsorption isotherm. Factors like pH, adsorbent dose, and the shaking time influence the rate of arsenic removal. So here I give you the information that I have uploaded in my paper based on the layered double hydroxide used for the removal of arsenic from water. So I have given you the paper, I have uploaded it so you can see the whole paper, and I hope you study it and you will get lots of information from this paper. Then nanomaterial in arsenic removal. With the advent of nanotechnology, the variety of adsorbents and their scope of application have been widened for the treatment of contaminated water. Nanoparticles like monocrystalline titanium dioxide, nanoscale zero valent iron with their large active surface area have shown promising results. Further, magnetic nanoparticles as an adsorbent are much better than conventional adsorption processes. Removal of arsenic with magnetite, that is Fe3O4, the oxide of iron, nanoparticles. So the highest level absorption capacity with small diameter nanoparticles for both arsenic 3 and arsenic 5. Iron oxide coated sand was used in many studies for arsenic removal. Iron compounds such as hematite, goethite, iron oxide coated materials, and granular ferric hydroxide are the preferred group of nanomaterials for arsenic absorption from drinking water. Now, reverse osmosis and nanofiltration. Size exclusion process is the basis of reverse osmosis and nanofiltration technique. Subjected to a pressure gradient, a semi-permeable membrane allows water to pass through while retaining certain ions. Reverse osmosis membranes are more selective than nanofiltration membranes. Due to higher selectivity, reverse osmosis systems require higher driving pressures, hence higher energy consumption. Arsenic rejection in reverse osmosis and nanofiltration is relatively insensitive to pH. However, arsenite, being anionic at high pH but unsensed at lower pH, is rejected more completely at pH greater than 8. Both reverse osmosis and nanofiltration are relatively expensive water treatment systems, consume large amounts of water, and generate a considerable amount of waste brine. There are other issues that limit the membrane life, which include the presence of suspended solids, microbes, hydrogen sulfide, iron and manganese, and organics. Therefore, typically pre-treatment is required to keep the system more durable. So here I am showing you a table where the removal of arsenic 3 and arsenic 5 from drinking water is shown, and here in the first column you see the different treatment processes. In the second and third respectively, the removal of arsenic 3 and removal of 5, then advantages, then the disadvantage of the processes, and the cost I have shown. And if we see the treatment process by iron coagulation, you see the arsenic 3 removal is 60 to 90% and 5 is greater than 90%. Advantages is very simple to operate, and efficiency is very high. Disadvantages, the pre-oxidation is required for better removal of arsenic 3. So arsenic 3 should be converted into arsenic 5 by oxidation to remove high percentage of arsenic from the water, and at the same time cost is low. Similarly, alum coagulation precipitation activity, alumina absorption, iron base solvents, reverse osmosis, nanofiltration, they have their different removal capacities, different advantages, disadvantages, and cost I have shown you in the table. Now let us see the different widely used arsenic removal technologies. But when you go for the using of the different arsenic removal technologies, we should have to see, we should have to see some of the important properties of methods of choice. So the desired properties of methanolysis are the technology or the technique or the method should be efficient in removing both arsenic 5 and 3, as because arsenic 5 and 3 both are present in the form of anions in drinking water. It should be robust, it should be safe, reliable and low on maintenance. It should be made of locally available materials. Monitoring required should be less. Unskilled labor should be able to operate it. So these are the main conditions when you go for development of a technique or development of a technology for the removal of arsenic. So when we go for the removal of when we go for the development of the technique, then definitely the technique should be safe, reliable, it should be eco-friendly, yeah, and the cost should be less, and if unskilled labor can operate the system, that it will be better, and at the same time it can remove arsenic 3 and arsenic 5. So among the most widely used techniques for arsenic removal, the three courses system is the is a very important one. So I will discuss all these techniques one by one. Uh, so trickle C, that is known as Gregory system, is widely accepted household arsenic removal unit being implemented in Bangladesh. The filter unit is based on a traditional water purification system, consists of three clay pitchers, or it is known as kalsi, stacked vertically in a frame. The top kalsi contains a layer of iron fillings and a layer of coarse sand. The middle kalsi contains a layer of charcoal and a layer of fine sand, and the bottom kalsi collects the filtered water. The operation procedure is very simple and no chemicals are required. And the cost is around 5 to 10 US dollar, and that is the minimum maintenance cost, but it should have some limitations also. uh, as for example, by this process, the contamination due to microbes cannot be removed. So fluoride is also very slow, very low. Fluoride is low, that is power per hour, it is 3 to 5 liter, and there is chance of clogging. So problem of cleaning and fragile. These are the some of the disadvantages, or you can say the limitations of triple C system. Now it is two C system, that is here in the two C system for scenario hill. The first in the very first step, sodium, a mixture of sodium hypochlorite, ferric chloride and acids mixed with the raw water. Then after mixing, it is filtered through sense, taken in a two pulse. The advantage of this system is very simple technique. It's very easy to use, and microbial removal and arsenic removal is high. But the limitation is that coagulant availability in rural areas. It requires time and work to mix, settle, and filter. So these are the two main limitations, and the cost is around 5 to 10 US dollar, and another 10 US dollar per household failure for chemical displacement for processing of chemicals or the filter media. Now, uh, another system that is biosym filter into BSF, known as BSF. So BSF is an indigenous, traditional, simple, slow sand water filtration device, particularly effective for discontinuous use. The filters are in use for water treatment at community or household level for hundreds of years. BSF consists of containers filled with sand and gravel where physical staining of flow water helps in removal of turbidity, iron, manganese, and pathogens from drinking water. The modified engineering design for the BSFs as slow intermittent filter was developed in the 1990s at University of Calgary, that is Canada, by Dr. David Munch. Most widely used version of BSF is usually made up of concrete with a cost of establishment ranging approximately between uh, 20 and 40 USD, and with a flow rate of 20 to 40 liters per hour. So again, it has disadvantages: the good arsenic removal, high flow rate, easy operation, but at the same time it has some limitations. uh, the manufacturing is not simple. uh, the media life is very short, that is up to 1 year, and the clogging is again one another problem here. Now, it is again a very good filter system, arsenic removal, that is known as Consum arsenic filter, KAF. The Consum arsenic filter, that is KF, is a variation of the Biosyn filter. It has been developed as the Consum TM filter, and it is shown in the figure under the Nepal Water Project in collaboration with MIT USA and Nepal-based non-governmental environment and public health organization. The filter can remove arsenic, iron, turbidity, and odor, and is useful for microbial water treatment without using any chemicals. So the main advantage is very simple and effective. Arsenic level is 85 to 95%, and the cost is around $20. Then let us come to the uh, sono filter. So it's a three bucket system with a composite iron matrix as the active arsenic elimination constituent, uh, shown in the figure. It works on the principle of surface complexation of arsenic on the composite iron mixer, followed by a filtration, and does not require any chemical treatment. Further, the production of toxic waste is negligible. The cost of the filter is around $40. It can produce 20 to 30 liter per hour arsenic free water. Sono filters have been well deployed all over Bangladesh and continue to provide more than a billion liters of safe drinking water. Now, another water arsenic removal unit, it is known as water deacidification unit, and actually it is developed by Defense Research Laboratory Tezpur. So Luckily, at the time of development of the filter, I was uh, doing research at Defense Research Laboratory Tezpur. So here the picture is given of the deer arsenic unit, and the advantage of this unit is filtration rate is 300 liter per hour. So it has different sizes. So by using this water dearsonation unit, and arsenic highest arsenic removal was observed 99.55% when 252.95 ppb arsenic contaminated water was used, and similarly when you increase the concentration level of drinking water, the removal rate is going to be decreased. So here it is shown that after when I used when I used 909 ppb arsenic contaminated water, it can remove up to 96.71% arsenic removal. So advantage of this water dearsonation unit is adequate aeration, removal of major portion of arsenic in the sedimentary chamber, filter with cracking prevented and clogging delayed, double filtration ensures better arsenic removal, and it has a pre-washing system. It is user friendly, suitable for community use, and very easy in the operation and maintenance system. Now this is again another system that is known as phytoremediation. The water hyacinth plant rose can be used for the removal of arsenic. By using this technique, we can remove 93 to 95% arsenic from drinking water, but it has the limitations. Limitations of technology is still under develop. Where to obtain this plant. So when you go for the development of the technique of this technique, we should have the availability of the plant material and the region, and how to prepare the powder as a problem, and thus its safe disposal is another problem. Cost is still unknown, but probably inexpensive. So phytoremediation is an eco-friendly method of contaminant of arsenic pollution. It provides a safe method for the disposal of arsenic against block, but it has some limitations also. This method is still in the infant stage. Long-term effect of this on our environment is yet to be explained. Very slow process. It can take 20 years or more to clear a particular area, and it cannot provide the safe drinking water to the people in need of it immediately. So these are some other plants also, aquatic plants by which you can remove arsenic from drinking water. So the study is done by myself, and I had a project in the year 2018-2020 where two of my students of BSc chemistry major, they have done the experiment, and from the experiment it has been observed that the plant species Pistia stratitus can remove 82.6% arsenic, followed by 45% by Salvinia natans, and 21.10% by Azolla pinnata, respectively, when these species were cultured in 1 ppm solution of arsenic. 73.76%, 60.93%, and 34.0% arsenic level were observed for species Pistia statutes, Salvinia natans, and Azolla pinnata, respectively, also after culture in 3 ppm arsenic for 8 days at normal laboratory conditions. Similarly, the recorded values of arsenic removal by phytoremediation in 5 ppm arsenic solution for 8 days were 71.66%, 71.02%, and 28.50 ppm percent for species Pistia statutes, Salvinia natans, and Azolla pinnata, respectively. It has been observed that the plant species Pistia statutes has highest arsenic removal capacity, that is 82%, 73.76%, and 71.68% for 1 ppm, 3 ppm, and 5 ppm arsenic concentrations, respectively. So now let us come to the end of the presentation, that is nothing but a conclusion. So for removal of arsenic, several physiochemical techniques are common. Among them, lime softening and iron core precipitation have been tested as the maximum effective removal technologies. A couple of simplified systems are widely used in Bangladesh and West Bengal, although there are operation and maintenance problems. The existing arsenic removal technologies, along with newer avenues, require further improvement to make them appropriate for their large-scale, user-friendly, and sustainable for their large-scale effective users. So, student friends, so these are all about my today's presentation. I hope you understand and the topic, and I hope you will be benefited by this presentation. At least you will be able to know, you will know how to remove arsenic by different processes from drinking water, and which is actually very urgent need for the human being. So lastly, I want to conclude my presentation. Thank you all.